Hey guys, it's Mr. Post, and on today's video, the goal is to learn how to name covalent or molecular compounds. It's a new lesson. It's a little different from how we named ionic compounds. When we named ionic compounds, an ionic compound we had studied was NaCl, and we named this sodium chloride. And this compound down here is a poisonous, odorless gas that you actually have a detector for in your house, and that is carbon. Maybe you can guess it. Carbon monoxide. And we also have something that we exhale, and it's also a very big greenhouse gas, and that is going to be carbon dioxide. All right, so we have carbon monoxide and carbon dioxide and sodium chloride. One of the things you're going to notice is that sodium chloride, I do not use a mono or a di for that. Okay, I did use a mono down here, so I have Na1, CO1, and C1O1, and I happen to use mono when I name this, and I happen to use di when I name that, but I did not do that for NaCl. NaCl is an ionic compound, and in ionic compounds that have metals and also nonmetals, I do not need to use prefixes such as di and tri. And in today's lesson, you're going to see that I'm going to teach you how to name covalent compounds. Covalent compounds, like these compounds, are all composed of nonmetals. Both elements are nonmetals. And we're going to need to use dis and tris and monos in order to name them correctly. A good example of reason why. Traditionally, if you're naming this with ionic naming rules, this would be C1O1 carbon oxide. And this would also be C1O2. That would still be carbon oxide. But the point is, in covalent bonds, I can have more than one combination. All right. As you see here, I have at least two, and I can have more than two combinations of the same elements. So I can't just name this carbon oxide anymore. I have to actually name it now carbon monoxide or carbon dioxide to differentiate between these two. Same way down here, I need to differentiate between which hydrogen oxide I'm talking about. And this one is H2O2, and this is H2O1. Well, if I just say hydrogen oxide, you can't really tell which compound I'm talking about. I would refer to this as dihydrogen dioxide or dihydrogen monoxide. So we're going to use prefixes, all right? Prefixes coming before these names, carbon dioxide. Di becomes before oxygen. Prefixes used for when we name these molecules. I'm going to show you the prefixes that we use now. They're going to be mono, di, tri, tetra, and penta. Pause if you need to. And on the other side here, we're going to go up to 10. We have hexa, hepta, octa, nona, and deca. And these are the prefixes we'll be using while we're naming our molecules. We have a few rules we need to go over when we name these molecules. The rules are going to be pretty easy. That we're going to use prefixes, all right, on both of the nonmetals. Not just the last one, but on both of the nonmetals. And the last element, as always, ends in IDE. One of our exceptions here is this. If I happen to have a prefix that is mono, okay, I'm not going to use it for the first element. This is one of the rare exceptions when we do not use a prefix. A prefix mono is not used, and is only not used on the first element. And a good example we just saw is carbon monoxide. This is C1O1. Now the prefix for 1 is mono, and that's why you see it over here, monoxide. The prefix for 1 is mono, again, and I should be seeing that mono right here. But the rule is telling you that whenever the first element has a subscript of 1, that is the only time we don't call out the prefix. Okay? If the prefix was 2 right there, we would definitely call it dicarbon. But because it's 1, we're not going to use mono in the first element. The other rule is this. Anytime I have 2 of any element just by itself, and I give you 2 examples. Let's just say I'm breathing in some O2 right now. You're going to call that oxygen. You're not going to call it dioxide. You're not going to call it dioxygen. It is simply called oxygen. This goes for any element that I have 2 of. I could have 2 fluorines. That's called fluorine. Nitrogen in the air. Most of the air we breathe is nitrogen. We'll call it nitrogen because it is N2. So anytime I have 2 of any one element by itself alone, I name the periodic table name, and I use that without an IDE ending. Let's get some practice in here. Okay, what is the formula of phosphorus trichloride? Well, here's phosphorus. Phosphorus is the element P. Chloride, that means chlorine. And tri is telling me that I have 3 chlorines. Well, there wasn't a prefix in front of phosphorus, so that means phosphorus was probably a 1, because mono is never used on the first element. So that's going to be phosphorus trichloride, PCl3. Carbon monoxide is one we already seen before. We have carbon and oxygen, and we have a mono in front of the oxygen, meaning C1O1. Once again, there's no prefix in front of carbon, so that means the prefix is actually 1, because otherwise a prefix would be mentioned. Okay, fluorine is one of those exceptions to the octet rule, not the octet rule, I'm sorry, one of the exceptions to the naming rule. All right, anytime I name an element fluorine, what I'm really saying is I have 2 of that one element. And dihydrogen monoxide, dihydrogen, H2, monoxide, O1, H2O. How about potassium oxide? Now this one I'm going to put a little trick here for, okay? I'm really trying to fool you on this one actually, because this is a metal and a non-metal. Anytime I have a metal and non-metal, I'm talking about an ionic compound. Okay, an ionic compound I simply have to put down as potassium is K, oxygen is O, and if you recall, we need to cross charges. So anytime you see an ionic compound being used, or a metal and a non-metal, I need to cross charges, and the formula is K2O, potassium oxide. And I want you to notice here that this is a non-metal, and this was a non-metal, this is a non-metal, and so is this. And this whole page is non-metals except down here. Potassium is my only metal, and ionic compounds are metals and non-metals, while covalent compounds are simply between non-metal and non-metal. Okay, once again now, this page I'm actually going to ask you a question first. Instead of tricking you, I'm going to give you this. The hint is, look for ionic or covalent first. Okay? Ionic compounds are metals and nonmetals. Covalent compounds are just nonmetals, because that affects how I name things. Okay, so I have carbon and bromine, tetrabromide. That's carbon and bromine. Carbon and bromine are both nonmetals, therefore this is a covalent compound. So it's going to be covalent. I'm just going to leave it as COV, covalent. Carbon, I have no prefix, that means I have a 1 after carbon. And tetra is the prefix for 4, CBr4. Magnesium oxide, check this out. Magnesium is actually a metal, and oxygen is a non-metal, so that means this is actually ionic. Ionic simply says, you write down the formula, cross the charges, the 2's cross places down here, and I reduce the 1 and 1. The formula is MgO after I reduce. Dihydrogen, okay? So I got a di in front of there and a tri. Dinitrogen, rather, trichloride. Okay, dinitrogen, that's N2, trichloride. That's chlorine with 3 there. Sodium sulfate, okay, I have no prefixes here, so anytime I have no prefixes, it's also another way of saying, ding, 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 you probably have an ionic compound. So there's no prefixes here whatsoever. It's an ionic compound. Sodium's a metal. Sulfur is a non-metal. Let's write out the formula and then cross the charges. The 2 goes down here. The 1 goes over here. And what I end up with is Na2S. All right, I have prefixes here. I have a di and a tri. And a di is going to be 2, and a tri is going to be 3. So I have diphosphorus. That's P2. Fluorine is 3. P2F3. Wow, look at this, guys. It's a little crazy here. All right, we've got a lot of elements going on here, a lot of compounds. Let's take these one at a time. First thing, as always, identified as ionic or covalent. That's a metal and a non-metal. So let me just put this up here. Metal plus non-metal for ionic, and covalent compounds are simply non-metals. I want to identify them first because that's going to be telling me how I name them. All right, so NCl3, that's a non-metal and a non-metal. All right, so therefore it's a covalent compound. Covalent compounds require prefixes. This is going to be nitrogen, trichloride. Oops. I apologize if you can't read that. That's nitrogen trichloride. Here I have sulfur and fluorine. Both of these are non-metals. Non-metals mean I'm going to be covalent. And this is going to be sulfur. Hexafluoride. Okay, guys, I want you to take a shot at now trying these on your own. I'm going to pause and I'll come back with the answers. Okay, guys, here's my answers. Maybe you want to press pause right now and check them out. The ionic compounds were magnesium oxide, sodium fluoride, and magnesium chloride. Those compounds I did not need to use the prefixes for. All the other ones I obeyed the prefix rules, and you'll see them as that. A couple key ones here. N2 is nitrogen. I just name the periodic table name anytime I have two of just one element. So I have two of just my pen's not working too good. Two of just this guy and two of just this guy. I call them the periodic table name. I use nitrogen and I use chlorine. But anyway, guys, read over the answers. It sums it up, okay? Hope you enjoyed it and hope it helped. Take it easy.